Example 1, simplify the following. Question A, we would like to make use of the rules of third in addition, where if I want to add up two thirds, I must make sure that they happens to be a common third such that they have a common third such that, let's say I have b square root of a, I add with c square roots of a, then I can simplify in the way of b plus c bracket square roots of a. It's as if like we have a common terms of square root of a, then we do factorizations. And what if, let's say I happens to have two different thirds, let's say square root of a and also square root of b. And let's say this is ca db, and I want to add up. In this case here, what happened is that this one is the case that we cannot simplify. It will just leave it alone in this form here. Then now, let's refer to example A, and we're going to apply this idea here. So you see we have the first bracket, a request to add with the second bracket. And let's see in the first bracket and second bracket, do we have any common third term there? And you will find out that 2 square root of 3, where we have square root of 3, 7 square root of 3, I have square root of 3. So by write these two, I can undergo the operation of plus, like what we see in the properties I explained just now. Whereas the other one, minus 5 square root of 2 and plus 2 square root of 2. We can happen to simplify that. And to have a better view, so let me rewrite the item there, where again, 2 square root of 3 plus with 7 square root of 3. I group them together. It turned out to become something like this, 2 square root of 3 plus 7 square root of 3. Minus 5 square root of 2 plus 2 square root of 2. And as a result, now, for the case I have common square root of 3, by the time I want to simplify my answer, it's just as if like the simple calculations in algebra, or you can refer to these properties here. The simple calculation in algebra as if like I have 2x plus 7x. So it will turn out to become 9x, and in this case here, it will turn out to become 9 square root of 3. Similar idea for the case behind, as if like negative 5y plus 2y. When the time I simplify, I get negative 3y. And therefore, this is the answer we have for A. Go on. For question B, the rules in subtractions for third is similar like the case that we have in addition, where if I want to do subtractions, I must happen to have the common third. For example, I have CA minus D square root of A, and this can be written as C minus D square root of A. Similar like just now, if let's say I doesn't have any common third, let's say I have A C square root of A minus D square root of B. You find out that the square root is happen to be difference. Therefore, this one we cannot simplify. At least at this point here with the unknown different, I cannot simplify. Go on. So in this case here, we're going to do the similar thing, and let's see. We have the first bracket minus the second bracket. And let's see, is there any common terms I have for the first and second bracket? And obviously you find out that in the first bracket, I have the common surd square root of 7 with the second bracket, such that I have 5 square root of 7 and 8 square root of 7. So from this thing here, we find out that I can have 5 square root of 7 minus 8 square root of 7. On the other hand, I also have common surd of square root of 5 for these two. And the operations I have is 3 square root of 5 minus negative square root of 5. And as a result, this is what I have initially. Then, as a result, your final answer, if it happens to turn out that, simplify this part for the square root of 7. We have 5 minus 8. And it gives us the answer of negative 3 square root of 7. 3 square root of 5 minus square root of 5. So you have the answer as 4 square root of 5. So once again, the idea of the calculation as if like 3y minus negative y, where the y is referred to the surd. So as a result, I have 4y. There goes the answer.